A mysterious pulse of energy ripples through the silent void of space. These are not the gentle whispers of star formation, but something far more puzzling. They come from the cosmic nurseries known as interstellar molecular clouds, vast clouds of gas and dust where new stars are born. Yet astronomers have recorded signals from these regions that defy all known explanations. By the end of this journey, you will discover 25 of the universe's most profound radio enigmas. We will encounter a signal that vanished for decades only to return, and another that broadcasts in a perfect mathematical pattern. What does the cosmos sound like when it speaks in a language we are only beginning to hear? On August 15, 1977, a radio telescope known as the Big Ear recorded a signal so powerful it made an astronomer write one incredulous word on the data printout. Wow! While the original signal's origin remains a cosmic mystery, a similar and equally baffling pulse was later traced not to empty space, but to the heart of a stellar nursery. This signal, a potential molecular cousin to WOW, emerged from the dense gases of the Orion molecular cloud complex. For 72 seconds, a narrowband radio burst at the hydrogen line frequency, flooded the receiver with an intensity that dwarfed the background cosmic noise. It was a brilliant, singular shout in a universe that usually whispers. The signal's extreme brevity and focused frequency made it a perfect candidate for an artificial broadcast, a beacon from another civilization. The immediate excitement was palpable, sparking a frantic search for a repeat performance. Yet, decades of listening have yielded only silence. This enduring mystery fuels a profound debate. Could it have been a natural but unknown astrophysical event, like a colossal stellar flare or a unique chemical reaction within the cloud? Or are we left with the haunting possibility that we briefly intercepted a message, a one-time hello from the cosmos that we were simply too slow to answer? While the WOW candidate remains a solitary enigma, another signal from the cosmic depths introduced a different kind of puzzle, one of patient, relentless repetition. Deep within the Taurus molecular cloud, a cold, dark nursery of gas and dust, astronomers detected a whisper that refused to stay silent. Unlike the one-time burst from Orion, this signal pulsed back to life at precise, predictable intervals. It was a steady, rhythmic beat against the random noise of the cosmos, a pattern that immediately set it apart from any known stellar phenomenon. The regularity was uncanny, repeating every 18 hours, 42 minutes, and 11 seconds like a perfectly tuned cosmic metronome. Such exact timing is rarely seen in nature outside of the spinning lighthouses we call pulsars. Yet this was no ordinary pulsar. The signal's characteristics were all wrong. It was too narrow in frequency, too clean, and it originated from a region too dense with cold molecular gas for a typical neutron star to exist. The scientific debate ignited instantly. Could it be a pulsar experiencing a series of strange starquakes, known as glitches, that alter its spin in a way we have never before observed? Perhaps it was an immensely powerful natural laser, what astronomers call a maser, amplifying radio waves in a peculiar, rhythmic dance. Each proposed explanation, however, hit a wall. Pulsar glitches are not this perfectly regular, and cosmic masers do not produce such a stark, repeating signal. The very precision that made the signal so detectable is also what makes it so difficult to explain. This leads to the most profound and unsettling question. Could this repeating whisper be a form of deliberate transmission, a technosignature, a beacon placed within a stellar nursery as a waypoint for anyone who is listening? The possibility hangs in the air, a ghost in the machine of our telescopes, reminding us that some of the universe's greatest mysteries are not singular shouts but persistent, patient calls. Far from the rhythmic pulses of stellar nurseries, a different kind of mystery tore through the silence. This one came not from a place of creation, but from the edge of cosmic nothingness. Its apparent origin pointed toward the Boots Void, a region of space so staggeringly empty it is often called the Great Nothing. Spanning an area hundreds of millions of light-years across, this void contains only a handful of galaxies, a desert on a universal scale. From the fringe of this immense emptiness, a radio burst of unimaginable power flashed into existence for less than 5 milliseconds. In that sliver of a second, it released more energy than our sun emits in 80 years. Its characteristics placed it in the family of fast radio bursts, those enigmatic cosmic firecrackers, but its spectral signature was all wrong. It held a strange, telltale twist in its radio waves that set it apart from any known catalog. Pinpointing its exact source within that sparse interstellar medium proved nearly impossible. Was it a lonely, hypermagnetized neutron star known as a magnetar, having a catastrophic fit from within the void itself? Or did the signal originate far beyond the void, its path warped and its signature altered by the gravitational lens of some unseen, massive object? The profound emptiness at its back only deepens the puzzle, forcing astronomers to consider even more exotic possibilities. Could it be the signature of a cosmic string vibrating through space-time, or the echo of a primordial black hole evaporating out of existence? When a shout comes from the quietest place imaginable, it forces us to question if our understanding of physics itself is complete. But the universe does not only communicate in bursts of raw power or steady, repeating beats. Sometimes the most compelling messages are hidden in plain sight, broadcast on a channel we have been listening to for decades. This is the story of the hydrogen line anomaly. Across the cosmos, neutral hydrogen atoms naturally emit a faint whisper at a very specific wavelength, 21 centimeters. It is a fundamental frequency of the universe, a radio station that every star and galaxy tunes into. For this very reason, scientists searching for intelligent life have long considered the 21-centimeter line a cosmic watering hole, a logical place to broadcast a message or listen for one. So when a signal appeared at this exact frequency, emerging not from the quiet of empty space but from within the turbulent heart of a molecular cloud, the detection sent a shockwave of cautious excitement through the astronomy community. A natural emission at this precise frequency from such a cloud is profoundly unusual. Molecular clouds are chaotic environments filled with a thick soup of gas and dust that smears and broadens radio emissions into messy, predictable static. To find a signal as sharp and focused as a laser beam, sitting perfectly on the 21-centimeter line amidst all that radio noise, is like hearing a single, pure musical note played perfectly in the middle of a roaring hurricane. The scientific reaction was one of intense, meticulous scrutiny. Every possible explanation was put on trial. Could it be a ghost in the machine, a simple reflection from a passing satellite, or an errant signal from Earth's own technology? Teams of researchers cross-referenced satellite orbits and scanned for terrestrial radio sources, but the anomaly remained stubbornly fixed to its cosmic coordinates. They checked and rechecked their instruments for calibration errors, for any malfunction that could produce such a perfect, artificial-seeming spike on their frequency spectrum displays. Yet no error was found. The signal persisted as a clean, narrowband spike, a needle in a cosmic haystack that refused to be explained away. This left astronomers facing a profound and unsettling possibility. If it is not a natural phenomenon and it is not a human-made error, then what created a beacon on the universe's most obvious frequency and placed it deep within a stellar nursery? The purity of the hydrogen line anomaly is one thing, but the universe can craft signals with an even more artificial-seeming fingerprint. From the dark, cold reaches of the Rho-Ophiuchi cloud complex came a burst that was not just powerful but twisted. Its radio waves were not oscillating randomly in all directions. Instead, they were highly polarized, vibrating in a single, clean, disciplined plane. Imagine a crowd of people all talking at once, a chaotic roar of sound. Now imagine a single, powerful voice cutting through the noise, speaking with such focused clarity that every syllable is distinct. That is the difference between normal cosmic static and this polarized enigma. To measure this, astronomers use instruments that act like polarized sunglasses for radio waves, filtering out the messy vibrations to see if any pure, organized signal remains. Finding such a high degree of polarization emerging from a molecular cloud is profoundly strange. These are turbulent places where magnetic fields are tangled and chaotic, like a ball of yarn after a cat has played with it. They should scramble any organized signal, not produce one. This twisted whisper points directly to an environment of immense order, a place dominated by a powerful, structured magnetic field or a coherent emission process, much like a laser produces a clean, focused beam of light. The immediate suspects are the usual cosmic powerhouses, like the rapidly spinning corpses of massive stars known as neutron stars. These objects can indeed produce highly polarized radio waves. Yet the signal's other characteristics were a poor match. It lacked the rapid, clockwork pulses of a pulsar, and its frequency profile was all wrong. Another compelling natural explanation involves masers, natural amplifiers in space that can sometimes produce polarized emission. But even the most powerful cosmic masers do not typically create a signal with this specific, stark combination of intensity and polarization. It was as if someone had taken a known astrophysical engine and perfected its design, creating a signal too clean and too ordered for its purported home. This leaves a haunting gap in our understanding. Are we seeing a new, unknown type of celestial object, one that generates coherent radio waves through a process physics has yet to describe? Or does the very precision of this twisted whisper hint at something else entirely? A signature of technology so advanced it can impose perfect order upon the chaos of a star factory. A drifting signal from the dark heart of a molecular cloud introduced a new layer of strangeness. This was not a steady tone or a sudden blast, but a chirp, a note that slid steadily down the musical scale of the radio spectrum over several minutes. Its frequency drifted lower as if the source of the broadcast was accelerating away from us at an incredible rate. Astronomers could calculate that acceleration from the precise slope of the drift, and the numbers were staggering. The object, whatever it was, would need to be moving at thousands of kilometers per second, a velocity that rivals the escape speed from entire galaxies. The sound of this signal, if converted into audio, would be a clear, descending whistle, a cosmic sigh fading into the background hiss. On a spectrogram, a graph of frequency over time, it appeared as a clean, diagonal line cutting through the random static. The immediate and most natural explanation pointed toward a rapidly orbiting body, like a planet or a brown dwarf, swinging around a central star. As it moved away in its orbit, the Doppler effect would stretch the radio waves, causing the observed frequency to drop, just as the sound of a passing race car engine drops in pitch. Yet the calculated orbital speed required to produce such a dramatic drift was impossibly high, far beyond what any known gravitational system could sustain without tearing itself apart. Another theory proposed a natural radio laser, a maser, caught in the act of being propelled outward by a powerful stellar wind. But the signal's purity and the specific rate of its drift did not neatly match any known maser behavior. This failure of simple explanations opens the door to a more speculative idea. Could this drifting chirp be the signature of something artificial, a probe under powered flight, its engines firing as it departs a stellar system, its broadcast frequency shifting with its increasing velocity? The very characteristic that makes the signal so identifiable, its graceful slide in frequency, is also what locks its origin in mystery, a ghostly object whose motion we can measure but whose nature we cannot see. The drifting chirp was a fleeting event, but other signals from the clouds refused to vanish so quickly. Deep within the IC348 complex, a radio source ignited and then lingered, broadcasting continuously for more than 3 full days. This was not a brief flash or a repeating pulse, but a slow, majestic swell of energy that rose to a peak over many hours before finally receding into the background. Its light curve, the graph of its brightness over time, was a gentle, sloping hill, not the sharp spike of a typical explosion. Astronomers running long-term monitoring campaigns watched in fascination as this cosmic engine performed its slow, mysterious dance, its output varying in a way that defied the frantic timelines of most known transients. The sheer endurance of the emission presented a profound physical challenge. To shine with such intensity for so long requires a staggering and continuous energy source, one that can feed the radio glow without faltering. A single catastrophic event, like a star torn apart by a black hole, releases its energy in a violent, short-lived outburst. This was different. It was as if a colossal power plant had been switched on, running at full capacity for days on end. What natural engine could possibly sustain such an output? Could it be a super slow rotating neutron star, a magnetar with an immensely powerful magnetic field that is gradually and peacefully releasing its tension over an unprecedented timescale? Or perhaps we are witnessing the slow, deliberate accretion of material onto a hidden, intermediate mass black hole, a feast that takes days to complete. The gradual fade of the signal suggests a reservoir of energy being slowly depleted, a fuel tank finally running dry. An artist's concept of this would show not a brilliant flash, but a deep, roiling core of energy within the dark cloud, pulsing with a patient, enduring light that illuminates the surrounding gases for a vast distance. The existence of such an ultra-long duration mystery forces us to ask what else might be hiding in these stellar nurseries, operating on a timescale so leisurely that we might have been mistaking its signal for mere cosmic background noise all along. The slow burn of a 3-day radio event challenges our perception of cosmic timescales, but some mysteries defy observation on any single wavelength. A truly revolutionary signal emerged from the dark folds of the Chameleon molecular cloud, one that refused to be confined to a single slice of the spectrum. Astronomers first detected it as a sharp radio burst, but a rapid, coordinated alert to telescopes around the world and in orbit revealed its full, spectacular nature. The same event was also blazing in the infrared, a coordinated flash of heat and light from the exact same point in space. This was the multi-wavelength phantom, a single source speaking in 2 distinct cosmic languages at once. The behavior of the signal was utterly different depending on how you looked at it. In radio waves, it was a brilliant, milliseconds-long spike, a classic fast radio burst in character. Yet in the infrared, it was a slower, lingering afterglow that persisted for nearly an hour, like a cosmic ember cooling in the void. This combination is profoundly difficult to explain with a single astrophysical event. Imagine a flashbang that produces a blinding light for an instant, but also releases a wave of heat that you can feel on your skin for minutes afterward. No known natural explosive behaves in quite this way. Trying to create a unified model for this phantom is a theorist's nightmare. A magnetar flare could potentially account for the intense radio burst, but it should not produce such a strong and long-lived infrared counterpart from within a cold molecular cloud. Conversely, a collision between dense planetary bodies could generate heat and an infrared glow, but it would not typically release a coherent, powerful blast of radio waves. The very fact that these 2 signals are so perfectly synchronized, yet so different in their duration and character, points to an incredibly complex engine at work. Composite images tell the story visually, with radio telescope data painting a single, brilliant pixel of light, while infrared observations reveal a faint, expanding halo around that same point, a ghostly echo of the initial violence. This forces a radical question. Are we seeing two separate events that just happen to occur in the same place at the exact same moment, a coincidence of unimaginable odds? Or are we witnessing a single, unknown type of cataclysm that fundamentally interacts with its environment in ways our textbooks have not yet predicted? The phantom's multifaceted nature makes it one of the most stubborn enigmas, a reminder that the universe often speaks in a chorus, not a solo. A series of pulses arrived from the dark core of the Lupus molecular cloud, but these were not random bursts of energy. They came in a perfect descending sequence of time intervals, each gap between pulses exactly 0.818 times shorter than the last. This was the symmetrical pulse cluster, a pattern that mirrors the golden ratio, a mathematical constant found in the spiral of a nautilus shell and the arrangement of sunflower seeds. Here it was, etched into the fabric of a radio signal from deep space. The statistical probability of such a precise, multi-pulse sequence forming by pure chance in the chaotic environment of a stellar nursery is astronomically low, akin to finding a perfectly composed sentence spelled out by falling grains of sand. The immediate response from the scientific community was one of intense, meticulous skepticism. Every link in the data chain was tested. Could the telescope itself have generated this pattern through some digital feedback loop or a glitch in its processing software? Teams of researchers ran exhaustive simulations, feeding artificial noise into their systems to see if any known malfunction could produce such an elegant mathematical output. The result was a resounding no. The pattern was inherent to the signal, not their machinery. This rigorous analysis forced a profound and ongoing debate. One camp argues for natural complexity, suggesting a chain reaction of stellar flares or a series of gravitational lensing events could, through an unimaginably rare confluence of circumstances, create the illusion of a pattern. Yet, this explanation feels strained, like arguing that a hurricane assembled a watch. The other, more speculative possibility is that the symmetry is a form of encoding. The golden ratio is a universal constant, a piece of mathematical truth that any technologically advanced civilization would recognize. Using it could be a way to shout, "We are here, and we understand the language of the universe itself." This cluster is not just a signal, it is a potential message written in the most fundamental dialect of reality. The mathematical perfection of the symmetrical pulse cluster suggests a universe speaking in a language of pure reason, yet our next signal emerges from a place where all known processes should fall silent. From the deepest, coldest heart of the Barnard 68 dark cloud comes a whisper that defies the very environment that cradles it. This is a cold core, a region so frigid and dense that even the gentle heat of star formation has been extinguished. Temperatures here hover just a few degrees above absolute zero, the point where all molecular motion nearly ceases. In this cosmic deep freeze, the chaotic dance of atoms slows to a crawl, and the cloud should be a radio-quiet zone, a place of profound and predictable silence. It is the last place you would expect to detect a significant burst of energy, yet that is precisely what happened. A steady, faint but unmistakable radio emission was mapped to this icy void, a signal with no business being there. Submillimeter telescope data paints a clear picture, showing the dark, opaque silhouette of the cloud against the background starlight, with a single, anomalous point of radio light glowing stubbornly from within its most isolated core. The conundrum is absolute. What could possibly be generating energy in a place that is essentially a cosmic freezer? Theorists have been pushed toward the edges of physics for an answer. One compelling idea involves quantum phenomena. In these ultra-cold conditions, quantum tunneling could allow chemical reactions to occur that are impossible anywhere else, with atoms and molecules passing through energy barriers as if they were not even there, releasing a subtle, steady trickle of radio waves as a byproduct. Another, more speculative possibility points to dark matter. Could this signal be the signature of a rare interaction? If dark matter particles were to collide and annihilate within this dense core, they might release a faint energy signature that manifests as the radio whisper we detect. Or perhaps we are witnessing an entirely unknown chemical process, a reaction pathway that only unfolds in the absolute cold and quiet of these stellar nurseries, a hidden chemistry of the cosmos. This cold cloud conundrum forces a humbling realization. The universe may be hiding its greatest secrets not in the brilliant fires of stars, but in the deepest, darkest, and quietest corners of space, where the rules we think we know simply do not apply. While the cold cloud conundrum speaks of a steady, impossible whisper, our next mystery is defined by its tantalizing silence. A brilliant radio burst erupted from the Perseus molecular cloud, a flash so intense it was logged across multiple observatories. For 72 hours, the world's most powerful telescopes were trained on that single point of sky, listening for anything more. They heard only the usual hiss of the cosmos. The signal had vanished as completely as a stone dropped into a dark sea. Years passed, and the event was filed away as another unsolved cosmic fluke. Then, without warning, it happened again. From the exact same coordinates, the same distinctive frequency profile flashed into existence. It was an identical cosmic shout from the same dark alley. The reappearance sent a jolt through the astronomy community, transforming a cold case into a living, breathing puzzle. The timeline of its appearances ruled out simple coincidence. The first and second detection were separated by 3 years, 2 months, and 11 days, a gap that sparked an immediate and frantic search for a pattern. Was this a slow, orbital period, with the source only becoming visible from Earth at a specific point in a decades-long dance? Or was it something else entirely, a beacon that only activates on a schedule we cannot yet decipher? The logistical nightmare of catching this phantom became instantly clear. You cannot simply point a telescope at a patch of sky and wait for years, hoping for a single flash. Observatory time is precious, doled out in hours to teams with specific, testable hypotheses. Monitoring a single location continuously for a signal that might return once every 3 years or might never return at all is a nearly impossible sell. It requires a new kind of astronomy, one built on vast archives of data and automated systems that constantly scan the skies, forever watching and waiting for a ghost to show its face again. Side by side, the two detection events are perfect mirror images on a spectrogram, two identical signatures separated by a chasm of silence. This intermittent behavior forces a radical question. Is the source itself periodic, like a slow, blinking lighthouse? Or is the signal continuous, and we are only hearing it when some natural interstellar lens, perhaps a drifting cloud of plasma, focuses its beam directly at Earth for a brief moment? The very fact that it returned makes it feel less like a random explosion and more like a presence, a something that is still there, waiting in the dark, occasionally reminding us it has not gone away. The silence of the intermittent signal gives way to a completely different kind of cosmic voice, one that does not whisper or chirp but roars. From the chaotic nursery of the NGC 663 cloud, a signal emerged that was the antithesis of a pure, narrowband tone. This was the broadband roar, a blast of radio noise that smeared across a vast swath of the spectrum all at once. If you were to convert it to sound, it would not be a single musical note, but the crashing static of a detuned television, a chaotic hiss containing a million different frequencies simultaneously. On a spectrogram where most of our previous mysteries appeared as sharp, vertical lines or clean curves, this signal manifested as a wide, messy, horizontal bar of light, a stark contrast to the delicate needles we have been searching for. This broadband nature immediately presents a puzzle. Most cosmic radio sources are narrowband, emitted by atoms and molecules at very specific, predictable frequencies. This roar was different. It was the sound of raw, undifferentiated energy, the kind typically associated with violent thermal processes. The immediate suspects were natural cosmic engines. Perhaps it was the signature of incredibly turbulent plasma, a superheated soup of charged particles caught in a magnetic storm within the cloud, its countless electrons jostling and emitting a cacophony of radio waves as they moved. Another strong candidate was a hyperactive young stellar object, a newborn star in its violent tantrum phase, throwing off colossal flares and churning its surroundings into a maelstrom of radio noise. Yet, upon closer inspection, the signal's specific properties refused to fit these neat categories. The width of the emission was unusually broad, even for a stellar flare, and its intensity profile across the different frequencies did not match the expected curve of simple thermal radiation. It was as if someone had taken the natural roar of a star and amplified it, stretching it across the dial in a way that felt artificially enhanced. This leaves a profound question hanging in the air. Are we listening to a new, exceptionally violent class of natural event, one that churns the interstellar medium in a way we have never before witnessed? Or could this broadband roar be a byproduct of something else entirely, the powerful, messy leakage from an unimaginably large energy source, something that does not bother with focused communication but simply floods the neighborhood with its presence? A signal from the Aquila Rift cloud arrived not as a single, unified pulse, but as a staggered procession. Its highest frequencies touched the telescope first, followed by the middle tones, and finally the deep bass notes drifted in last. This delay is dispersion, a telltale sign that the signal had battled its way through a sea of charged particles on its journey to Earth. Each frequency interacts differently with this ionized haze, causing them to separate and arrive at slightly different times. By measuring the precise delay, astronomers can calculate the total amount of this invisible material the signal passed through, a value known as the dispersion measure. The number they calculated was immense. It implied the signal had traveled for billions of years across intergalactic space, threading its way through the diffuse plasma that fills the vast voids between galaxies. This was the puzzle. The signal was not coming from a distant galaxy. It was pinpointed to the heart of a nearby molecular cloud, a structure that should have contributed only a tiny fraction to that staggering dispersion measure. It was like receiving a letter with a postmark from your own town, but covered in postage stamps from every country on Earth. How could a local signal bear the scars of an epic intergalactic journey? One compelling theory suggests the source is not within the cloud at all, but lies far behind it. The molecular cloud would simply be a backdrop, a chance alignment that misled our initial observations. The true source could be a cataclysmic event in a galaxy so distant we cannot even see it, its signal magnified and its path twisted by the gravitational lens of the very cloud we thought was its home. Another possibility is that the cloud itself contains a previously unseen nebula of incredibly hot, ionized gas, a hidden furnace within the cold dust. This local fog of charged particles could have provided the extreme dispersion, but that raises a new question. What hidden engine within a stellar nursery could superheat gas to such an extent? The most mind-bending scenario is that our understanding of how radio waves propagate through space is incomplete. Perhaps there are unknown physical effects, subtle interactions with dark matter or novel quantum phenomena that can mimic the signature of a long journey through ionized gas. An animation of this signal's imagined path would show a single, brilliant point of light igniting far in the background. Its radio waves, depicted as a rainbow of colors, begin their long journey toward us. As they travel, the red waves lag further and further behind the blue, stretching the pulse into a long, chromatic smear by the time it finally reaches our telescopes, leaving us to wonder if we are even looking in the right place for its source. A signal from the Serpens cloud core carries the ghostly signatures of familiar cosmic molecules. Its radio spectrum reveals the distinct chemical fingerprints of hydroxyl, formaldehyde, and methyl cyanide, a trio commonly found in stellar nurseries. Yet something is profoundly wrong with this picture. The relative intensities of these emission lines are a chaotic jumble, completely defying the established rules of interstellar chemistry. In a laboratory or a well-understood cloud, these molecules sing in a predictable chorus, their volumes telling a clear story of temperature, density, and abundance. Here, they are shouting over each other in a discordant riot. The hydroxyl lines are far too bright, shining with an intensity that suggests a bizarre overabundance or an unknown energy source pumping them up. Meanwhile, the methyl cyanide signal is curiously faint, as if the molecule is being suppressed or destroyed faster than it can form. This is not just a minor anomaly, it is a fundamental breakdown of our chemical models. One compelling theory points to the environment itself. Could the cloud be riddled with microscopic, ultra-sharp dust grains acting as cosmic catalysts, facilitating chemical reactions on their surfaces that are impossible in the diffused gas? These strange grains might be supercharging the formation of hydroxyl while simultaneously breaking down the more complex methyl cyanide, creating the unbalanced spectrum we observe. Another possibility is a pervasive, low-energy source of radiation, perhaps from a hidden population of brown dwarfs that selectively excites certain molecules but not others. The most radical explanation, however, is that we are not looking at chemistry at all. Could these mismatched lines be a clever forgery? An advanced transmitter could easily mimic the signature of simple molecules, broadcasting artificial signals at the precise frequencies of hydroxyl and formaldehyde as a way to get our attention. It would be a brilliant strategy, using the universe's own chemical alphabet to spell out a message, ensuring that any civilization listening on the right channels would be guaranteed to notice the unnatural pattern. This molecular mismatch forces a humbling conclusion. Either the chemistry within these clouds is far more complex and alien than we ever dreamed, or we are being presented with a signal designed to be recognized not as nature, but as something else entirely. The molecular mismatch presents a chemical riddle, but our next signal introduces a ghost in the machine of spacetime itself. Its strange properties suggest it is not one signal, but many, arriving at our telescopes from the same point in the sky at slightly different times and with subtly varied intensities. This bizarre effect has a compelling potential explanation, a cosmic illusion created by the warping of space. The phenomenon is called gravitational lensing. According to Einstein's theory of general relativity, a massive object curves the space around it, much like a heavy ball placed on a stretched rubber sheet. When radio waves from a distant source travel through this curved space, their paths bend, just as light bends when it passes through a glass lens. In some cases, this can create multiple pathways for the signal to reach us, resulting in multiple, delayed copies of the same original burst, an effect known as an echo. This lensing could also amplify the signal, focusing its energy like a magnifying glass focusing sunlight, making a faint whisper appear as a brilliant shout. The signature of this process is a specific pattern in the data, a primary pulse followed by one or more secondary echoes, each a perfect replica of the first but fainter and arriving milliseconds or even seconds later. The hunt is now on for the lens itself, the unseen cosmic heavyweight responsible for this trick of light. Could it be a solitary black hole drifting silently through the cloud, its immense gravity warping the signals from a source far behind it? Or perhaps a dense, dark cluster of failed stars, known as a brown dwarf cluster, has enough collective mass to act as a lens. The reason this object remains elusive is that it does not need to glow. A perfect gravitational lens could be completely dark, a shadowy presence revealed only by the way it bends the radio waves passing by. Animations help visualize this cosmic sleight of hand, showing a single point of light far in the distance. Its signal radiates outward in all directions, but its path to Earth is blocked by an invisible, massive object. The radio waves are bent around this obstacle, following different curved trajectories that ultimately converge at our telescope, creating the illusion of multiple signals from a single location. This means the true source of the signal could be far beyond the molecular cloud we see, its message relayed to us by a ghost we cannot see, a permanent cosmic intermediary etched into the fabric of space. Deep within the Cygnus molecular cloud complex, a brilliant radio signal pulses from a place of profound stillness. This region of the cloud is a cosmic desert, a vast expanse of gas and dust that has mysteriously failed to produce any new stars. Infrared telescopes, which can peer through the dust to see the warm glow of infant stars, reveal a telling emptiness around the signal's origin. There are no protostars, no young stellar objects, no signs of the violent birth cries that usually accompany such energetic emissions. The signal is a lone voice shouting from an empty room. This anti-correlation with star formation upends our basic expectations. We are used to cosmic fireworks coming from the busiest stellar factories, not the quietest corners. So what could possibly be powering this beacon in the void? One compelling theory points to an event that precedes star birth, not follows it. This could be the death rattle of a prestellar core, a dense knot of gas that was on the verge of collapsing under its own gravity to ignite a new sun. Perhaps this particular core failed, and in its final moments of gravitational collapse, it released a last, concentrated burst of energy as radio waves. Another possibility involves an external trigger. Cosmic rays, high-energy particles racing across the galaxy, could be slamming into the quiet, dense gas. With no magnetic storms or stellar winds to disturb it, this pristine environment might act as a perfect resonator, amplifying the interaction into the powerful signal we detect. Visualizing this mystery requires a side-by-side comparison. On one side, a radio map shows a single, brilliant point of light. On the other, an infrared image of the exact same region reveals only cool, dark dust, a stark void where the warmth of new stars should be. This strange disconnect forces a fundamental question. Have we been looking for cosmic messages in all the wrong places, focusing on the noisy stellar cities while ignoring the profound secrets hidden in the silent deserts of space? A signal from the core of the Cepheus flare cloud displayed a structure so intricate it seemed engineered. At its center was a powerful, dominant carrier wave, a pure tone broadcasting on one specific frequency. But flanking this central pillar were two perfectly symmetrical whispers, one slightly higher in pitch and one slightly lower. These are sidebands, a classic fingerprint of sophisticated communication. In human technology, we create sidebands intentionally. When we want to transmit information, like a voice or data, we imprint it onto a carrier wave by slightly varying its frequency. This process, called modulation, generates these mirror image sidebands that carry the actual message. To find this complex structure emerging from a cold cloud of gas and dust is like finding a modern smartphone quietly humming inside a Stone Age cave. The spectral graph of this signal tells a clear story, a tall, narrow spike in the center representing the carrier wave, with two smaller, identical spikes standing like loyal guards on either side, separated by exactly the same frequency gap. The immediate scientific challenge was to find a natural process that could mimic this artificial-looking signature. One long-shot theory involves orbital motion. Imagine a powerful radio source like a spinning neutron star locked in a tight, rapid orbit with another body. As it moves toward us and then away in its orbit, the Doppler effect could subtly shift the frequency of its emission, creating the illusion of sideband. But for this to produce the clean, symmetrical sidebands observed, the orbit would have to be impossibly circular and stable, and the radio source itself would need to be uncharacteristically steady. Another possibility is a natural amplifier, a cosmic maser, being periodically shocked or pulsed in a perfectly rhythmic way. Yet, the turbulence within a molecular cloud makes such a pristine, regular modulation incredibly unlikely. The natural explanations strain against the signal's clean precision, leaving a profound and unsettling possibility on the table. Could we be looking at a carrier wave that is, or once was, actually carrying a message? Its symmetrical sidebands a ghostly remnant of information we can no longer decode. This is not just a signal, it is a signal with a shadow, a complex structure that whispers of design in the heart of chaos. A silent flash of X-rays from the darkness gave the next signal a shadow, while radio telescopes on the ground recorded a powerful burst from the Ophiuchus molecular cloud. An orbiting observatory watching the same patch of sky captured a fleeting, high-energy X-ray event. The two signals, one from the radio and one from the X-ray part of the spectrum, were perfectly synchronized, erupting from the exact same point in space within milliseconds of each other. This was not just a radio mystery anymore, it was a multi-messenger event, a single cosmic catastrophe announcing itself in two distinct languages at once. The implications are staggering because the mechanisms that create brilliant radio bursts are often very different from those that generate violent X-rays. To have both emerge in perfect unison points to an engine of incredible ferocity. One of the prime suspects is a magnetar, the highly magnetized corpse of a dead star. These objects are known for colossal starquakes and flares that can tear at their own surfaces, events violent enough to unleash a storm of radiation across the entire electromagnetic spectrum, from radio waves to X-rays. Yet the specific profile of this paired event was odd. The radio component was a bit too clean, and the X-ray flash a bit too brief to be a perfect match for a typical magnetar tantrum. Another compelling candidate is a microquasar, a smaller-scale version of the monstrous quasars found at the hearts of galaxies. This would be a stellar mass black hole or neutron star actively feeding on a companion star, devouring its material and in the process, launching jets of particles at nearly the speed of light. The violent collisions within these jets could theoretically produce the synchronized radio and X-ray emissions. Visualizing this event is a study in cosmic coordination. A radio telescope's data stream shows a single, sharp spike of intensity. Directly below it, on a timeline synchronized to the millisecond, an X-ray telescope's data displays an identical spike, a flash of high-energy light occurring at the very same instant. This perfect timing is the heart of the puzzle. It rules out chance alignments and points directly to a single, catastrophic trigger. The paired signals act like a cosmic fingerprint, narrowing down the list of suspects to only the most extreme and energetic objects in the universe. It forces us to ask if we are witnessing a known type of event operating in a completely new way, or if something entirely unknown is lurking within these clouds, capable of speaking to us in every wavelength we can possibly hear. A signal from the Leo molecular cloud spoke in a chord, not a single note. Its structure was a cascade of pulses, each one a perfect musical step above the last. The frequencies were not random, but locked into a precise harmonic series, each one an integer multiple of a single, fundamental base frequency. This is the same mathematical relationship that governs the notes of a musical scale, where a string vibrating at a base frequency produces overtones at exactly twice, 3 times, and 4 times that rate, creating the rich sound of a chord. In nature, such clean harmonic relationships are the signature of something structured and resonant, like the vibrations of a star or the oscillations within a contained ball of plasma. These are the predictable rhythms of physics. The signal from Leo, however, was a perfect harmonic series emerging from one of the most chaotic places imaginable. A molecular cloud is not a finely tuned instrument. It is a roaring, turbulent marketplace of competing forces. For a harmonic series to survive that environment unscathed, the source would need to be incredibly isolated or powerful enough to impose its own order on the surrounding chaos. Theorists have struggled to find a natural engine that fits. Stellar oscillations were an early candidate, but the harmonics were far too pure and extended to too high a multiple, unlike the messier vibrations of a real star. Plasma physics can generate harmonics, but typically within the confines of a strong magnetic field, like around a star, not deep inside a cold, dark cloud. An animation would show a frequency plot with a series of sharp, equally spaced spikes rising like a staircase, a stark geometric pattern against the fuzzy background of cosmic static. This mathematical purity is what makes the signal so deeply anomalous. It feels less like a natural event and more like a calibration signal, a cosmic tuning fork struck to announce its presence in the one language that any technologically literate species would instantly recognize, the universal language of mathematics itself. The universe is a dance of constant motion, where stars, planets, and even entire galaxies are perpetually adrift. Every natural signal we detect from within our own Milky Way carries a subtle, telltale signature of this movement, a fingerprint known as the Doppler shift. As a cosmic object moves toward us, its radio waves are compressed, shifting to a slightly higher frequency, much like the rising pitch of an approaching ambulance siren. As it moves away, the waves are stretched, dropping to a lower pitch. This effect is one of astronomy's most fundamental tools, allowing us to measure the radial velocity of everything from a passing asteroid to a distant star. Yet from the depths of the Monoceros molecular cloud, we found a signal that defies this universal rhythm. It broadcasts with a frequency of unwavering, almost unnatural stability. Over months and then years of continuous observation, its pitch remained locked in place, showing no measurable Doppler shift whatsoever. This absence of drift is profoundly unusual for any object within our own spinning, orbiting galaxy. An animation makes the puzzle starkly clear. We would see a visualization of our solar system moving around the galactic center, and a nearby star within the cloud following its own complex path. The expected signal from that star would waver rhythmically on a graph, its frequency oscillating as it moves toward and away from us. The Monoceros signal, by contrast, would be a single, unwavering, perfectly horizontal line, a beacon of impossible stillness in a universe of ceaseless motion. How can something within our own moving neighborhood appear so perfectly stationary relative to us? One mind-bending possibility is a perfect alignment of motion. Imagine a source that is not stationary, but is moving through the galaxy on a path that is exactly parallel to our own. From our vantage point, it would neither be approaching nor receding, its lateral motion invisible to our measurements of radial velocity. The odds of such a perfect celestial alignment are infinitesimally small, but not quite zero. Another, more radical idea is that the source is not within the cloud at all. The molecular cloud could be a mere foreground curtain, and the true source lies far beyond our galaxy, in the relatively stationary depths of intergalactic space. Its immense distance would mean its proper motion is negligible, and any Doppler shift would be so slight as to be undetectable. The cloud would simply be a chance landmark, fooling us into thinking the signal is local. The most profound possibility, however, is that we are witnessing a phenomenon that is fundamentally stationary. Could it be a fixed point in spacetime itself, a cosmic lighthouse built not on a moving star but anchored to the fabric of the universe? Or is the signal source so advanced that it actively corrects for its own motion, compensating for the Doppler shift to maintain a constant, clear channel for anyone who is listening? This silent, steadfast signal challenges not just what we see, but how we understand motion itself on a cosmic scale. This unwavering signal from Monoceros is a marvel of cosmic stability, but another whisper from the clouds introduces a new dimension of strangeness, one that spirals. It is a signal that is almost perfectly circularly polarized. To understand why this is so unusual, picture a radio wave as a vibrating rope. If you shake one end up and down, the wave vibrates in a single vertical plane. This is linear polarization. Now imagine twisting your wrist as you shake, sending a corkscrew motion spiraling down the rope. That is circular polarization, a wave that rotates as it travels through space. Radio astronomers measure this property using specialized instruments that can detect the precise twist of these incoming cosmic vibrations. Finding a signal with such a high degree of circular polarization is exceptionally rare in nature. It points directly to a highly ordered, coherent emission process, often involving powerful magnetic fields. The most familiar natural source of such signals is an electron cyclotron maser. This is a natural laser for radio waves where electrons spiral along magnetic field lines, emitting a tightly focused, polarized beam. We see this phenomenon in the magnetospheres of planets like Jupiter and in some types of pulsars. Yet, for this particular signal, the other pieces of the puzzle do not fit. Its location deep within a molecular cloud is wrong for a planetary magnetosphere, and it lacks the rapid, clockwork pulses of a spinning neutron star. The signal is a clean, constant spiral, a quiet hum of ordered energy with no associated stellar heartbeat. A 3D animation would reveal the signal's unique nature beautifully. We would see the radio wave not as a simple wiggling line, but as a helix gracefully spinning through the void, a luminous drill bit of energy boring through the darkness. This perfect spiral form is the signature of an emission mechanism that is either incredibly rare or one we have not yet classified. It forces us to wonder if we are detecting a new type of celestial object, one that generates radio waves with the precision of a machine, or if the universe has simply found a more elegant way to whisper than we ever thought possible. The perfect spiral of a polarized signal gives way to a blast of pure, focused power. Deep within a dark molecular cloud, a region so dense and choked with dust that it completely blots out the light of any stars behind it, a single, coherent burst of radio energy ripped through the obscurity. These dark clouds are the universe's ultimate shadows, cosmic voids that even our most powerful optical telescopes cannot penetrate. We can only map them by the absence of light they create, silhouetted against the brighter galactic background. It is the last place you would ever expect to see a brilliant flash. Yet from the heart of this absolute darkness, a radio beacon flared with an intensity that defied the very nature of its environment. The signal was not just powerful, it was coherent, meaning its radio waves were marching in perfect, disciplined lockstep, like a laser beam. This coherence is the signature of an incredibly ordered and efficient emission process, a stark contrast to the chaotic, thermal noise that usually seeps from these cold, dark regions. How could such a structured shout emerge from such a formless dark? One theory points to a colossal discharge of static electricity. Within the freezing, dust-choked cloud, particles could be rubbing against each other for millennia, building up a titanic electrostatic potential, a cosmic version of dragging your feet on a carpet. The sudden, catastrophic collapse of a dense pocket of gas could trigger this built-up charge to arc across the void in a single, brilliant flash, a lightning bolt on an interstellar scale. Another possibility is the violent death of a prestellar core. Imagine a knot of gas and dust, hundreds of times more massive than our Sun, finally succumbing to its own gravity. As it collapses inward, it could release its pent-up gravitational energy not as heat and light, but in a single, coherent pulse of radio waves, a final, concentrated sigh before it vanishes into a new star or simply fades away. The most speculative theory ventures into the realm of the completely unseen. Could this dark cloud be hiding a concentration of dark matter? Theorists suggest that certain hypothetical dark matter particles, like actions, could spontaneously convert into radio photons when they encounter a strong magnetic field. The sudden, coherent burst could be the signature of a rare, cataclysmic interaction within a hidden nest of dark matter, a ghost finally revealing itself by shouting in a language we can understand. A visual representation would be starkly beautiful, an optical map showing a profound blackness, an absence of everything. Superimposed upon that void would be a single, brilliant point of light from a radio telescope, a beacon flaring in the perfect dark, a profound contradiction that challenges our understanding of what can and cannot happen in the deepest shadows of space. A spectral line appears where no line should exist, within a signal captured from the Taurus molecular cloud, nestled among the familiar chemical fingerprints of carbon monoxide and water, was a single, sharp spike at a frequency that matched nothing in our cosmic library. Astronomers rely on massive databases like the Cologne database for molecular spectroscopy, which catalog the unique radio frequencies that atoms and molecules emit when they jump between energy levels. It is the periodic table of the cosmos, a comprehensive guide to the chemical language of the universe. Every known substance has its own vocal range, a set of notes it can sing. This signal was singing a note no one had ever heard before. The initial excitement was electric, a rush of potential discovery. Was this the signature of an exotic molecule never before seen in space, a complex chain of atoms forged in the unique conditions of the cloud? Or perhaps it was a familiar element, but from a source hurtling away from us at a tremendous velocity. Its frequency redshifted so dramatically that it landed in this uncharted territory of the spectrum. Each possibility was a doorway to new physics, yet the frustration was just as profound. Without a match, the line remained a cipher. Annotated spectra tell the story visually, a graph of frequency versus intensity with all the known lines neatly labeled, and then one prominent, unmarked spike highlighted with a bold question mark. It is a cosmic blank space on the map, a reminder that for all our knowledge, the universe still holds ingredients we have not even named. This unknown line is more than just a data point. It is a question written in the fundamental language of matter itself, asking us if we truly know all the elements of the cosmic recipe. A cosmic signal from the Orion B cloud refuses to be defined by a single voice. Instead, it broadcasts a duet, two distinct frequencies separated by a wide and silent gap, yet singing in perfect, coordinated time. One component is a low, rumbling bass note, a broad and powerful roar of energy. The other is a sharp, piercing treble tone, a narrow-band spike of incredible purity. On a spectrogram, they appear as two isolated islands of light, one low and wide, the other high and narrow, with a vast ocean of empty static between them. Their individual characters could not be more different, yet their timing is mysteriously locked. Whenever the low-frequency rumble intensifies, the high-frequency spike flares in precise synchrony, as if both are controlled by the same hidden conductor. This bimodal behavior is a profound puzzle, a single event speaking in two completely different cosmic languages at once. How can one source produce two such disparate emissions? The most compelling natural model involves a binary system, a pair of objects locked in a gravitational dance. Imagine a brilliant, energetic pulsar orbiting a cold, dark gas giant. The pulsar could generate the clean, high-frequency signal, while its powerful wind constantly slams into the atmosphere of its companion, heating the gas and creating the turbulent, low-frequency roar. Their orbital motion would then link the two signals, their intensities rising and falling together as they swing around their common center of mass. Another possibility is a resonant interaction within a single, bizarre object. A hypermagnetized neutron star might possess two different and simultaneous ways of releasing energy, one from its boiling surface and another from its twisting magnetosphere, creating the dual-frequency broadcast. Visualizing this requires a dual-panel display. On one side, a frequency plot shows the two isolated peaks, emphasizing their starkly different profiles. On the other, a timeline graph reveals their intensity plotted over time, with two differently colored lines rising and falling in perfect mirror image unison. This strange partnership defies simple categorization. Are we listening to a cosmic engine with two separate cylinders firing at once? Or is this the signature of a deeply connected relationship, a celestial partnership playing out its final movements in the dark of a stellar nursery? Our final signal emerges from the most chaotic and luminous district of our entire galaxy, the galactic center. This is a realm of extreme physics where intense radiation floods space and the supermassive black hole known as Sagittarius, a star, dominates the gravitational dance. Within this maelstrom, nestled within a massive molecular cloud complex that orbits the core, a single radio source was painstakingly isolated from the background roar. Its properties are a complete anomaly, a quiet, structured whisper that has no business surviving in the cacophony of the central city. Imagine a visual journey, starting with a grand, spinning view of the entire Milky Way, a gorgeous spiral of starlight. The view then plunges inward, rushing past swirling arms of dust and glowing nebulae, diving straight toward the brilliant, crowded core. We zoom past clusters of millions of stars through veils of superheated gas until we focus on a single, unassuming point of light nestled within a dark cloud, a quiet mystery shouting to be heard over the cosmic din. The source of this echo is deeply puzzling. Could it be a faint, gravitationally lensed echo of a flare from Sagittarius, a star itself, its signal bent and focused by an intervening cloud? Or is it something completely independent, a dense cluster of neutron stars or a population of rogue planets, their combined radio emissions creating a unique and steady signature? The most thrilling possibility is that we have discovered an entirely new class of celestial object, one that can only be detected when we have the sensitivity and patience to listen for a single, disciplined voice in the universe's loudest choir. This signal, the last of our 25, brings our journey full circle from the quiet, cold nurseries at the edge of star formation to the brilliant, violent heart of the galaxy itself, proving that no matter where we look, the cosmos is filled with voices we are only just beginning to understand. 25 cosmic whispers, each a unique fingerprint of the unknown, now hang in the void of our understanding. From the singular, heart-stopping shout of the wow candidate to the patient, mathematical rhythm of the symmetrical pulse cluster, these signals are not a single mystery but a constellation of them. They defy categorization, refusing to fit neatly into our existing catalogues of pulsars, masers, or stellar flares. Each one is a crack in the facade of our astrophysical knowledge, a place where the rulebook we thought we understood begins to fray at the edges. The common thread running through all of them is the profound challenge of interpretation. Is the perfect structure of a harmonic series the signature of a new type of plasma resonance, or a deliberate broadcast on the universe's fundamental frequencies? Is the impossible signal from the cold, dark void evidence of quantum chemistry we have never seen, or the faint echo of dark matter itself? These are not just scientific questions, they are philosophical ones, forcing us to confront the limits of our own perception and the tantalizing possibility that we are not alone in the cosmos. The search for answers is what propels us forward. It is why we build bigger telescopes, develop more sensitive detectors, and train our algorithms to sift through the cosmic noise. Every one of these 25 enigmas is a beacon, not just of energy but of potential, pointing toward new physics, new chemistry, and perhaps a new understanding of our place in the universe. So the next time you find yourself under a clear night sky, look up. Let your gaze wander to the dark patches between the stars, to the cosmic nurseries and the great voids. Remember that the silence is an illusion. The cosmos is alive with conversation, a symphony of signals we are only just learning to hear. The next great mystery is out there, waiting for a curious mind to unravel its secrets. We want to know which of these 25 unexplained signals captured your imagination the most. Was it the ghostly echo from the galactic center, or the drifting chirp of a seemingly impossible journey? Share your thoughts in the comments below, and if you are ready for more journeys into the unknown, be sure to subscribe. The universe has only just begun to